Alright, this is another video about solving linear systems, but this time the method we're going to use is called substitution. So just like when you're solving by graphing, you're going to start with two equations. Now they may or may not be in slope-intercept form. What you do want to happen is you want one of the equations to be solved for one of the variables. That means you either want one of the equations to be x equals or one of them to be y equals. So in this case, since I have one that's y equals, that's the one that I'm going to use. And so you need to notice what it's equal to. Y is equal to 3x. So what we're going to do is we're going to substitute that. We're going to take that 3x, and since it's equal to y, we're going to substitute it, put it in place of y in the other equation. So if I do that, then this becomes 2x plus 3x equals 15. And now I have like terms that I can combine together. So 2x plus 3x makes 5x. 5x equals 15. Divide by the 5, and x equals 3. So I've solved for x. Now I'm going to put that back in one of the equations, and that way I can solve for y. So I'm going to use this second equation. So this is going to be y equals 3 times 3, the value of x I just found, and that is 9. So the solution for this system is going to be an ordered pair, just like it would be if I graphed two lines and I found the point where they intersected. So the x values first and the y values second. So my solution is 3, 9. So that is our solution for this system. So let's look at another. So let's say that we have y equals 2x minus 5 and y equals 4x minus 1. So notice in this system that you already have both of the equations solved for y. So it doesn't really matter which one I take and put in for the other one. I'm going to take this 4x minus 1 and put it in place of the y in the other equation. I could have also done it the other way around. So that's going to give me 4x minus 1 equals 2x minus 5. At this point, you're going to need to remember what we know about solving equations. So since I have variables on different sides of the equal sign, I'm going to subtract 2x from both sides to get all of my x's on the same side. That's going to leave me with 2x minus 1 equals negative 5. Add the 1 to both sides. 2x equals negative 4. And divide by 2. X equals negative 2. Okay, now I'm going to take this x I just got and put it back into that equation that I was using to substitute things with. So I'm going to take this negative 2 now and put it back in here. So this is going to be y equals 4 times negative 2 minus 1. That's going to be negative 8 minus 1, which is negative 9. So my solution is negative 2, negative 9, because it's the x and y value put together to make it an ordered pair. Alright, so let's say that I have a system that looked like this. X plus 2y equals 13. 3x minus 5y equals 6. So what's different about this system is I do not have either equation where I've got an x equals or a y equals. So I need to solve for the x or solve for the y in one of them, and I'm just going to pick which one is the easiest. So if there is anything that's already a 1, like a 1x or a 1y, that's going to be easy to get by itself. So like this first equation is going to be really easy to get this x by itself. So that's what I'm going to do. Over here to the side, I'm going to subtract my 2y so that I now have an x equals equation. X equals negative 2y plus 13. Then I'm going to take that, negative 2y plus 13, and put it in place of x in the other equation. Now notice this time there's a number in front of the x. We haven't had that in any of our examples. So I'm going to write that 3, and then this part I'm substituting in, I'm going to put it in parentheses, because that 3 is going to need to get distributed and multiplied times all of those parts. So that's going to make this negative 6y plus 39 when I multiply the 3 times the negative 2 and the 3 times the 13. I'm going to combine my like terms. Negative 6 minus 5 is going to make that a negative 11y. Subtract the 39. So now we have negative 11y equals negative 33. Then divide, and that's going to give me y equals 3. Now I'm going to take that and I'm going to put it back in place of y in that equation, that one I used to substitute earlier. So that's going to be x equals negative 2 times 3 plus 13, and that's going to give me 7. X equals 7. So if I put my x and y values together, that gives me the ordered pair 7, 3, and that is the solution for my system. Okay. Now, I know this has taken a little while, but I want to show you what happens. So you remember, we don't always get an answer. Sometimes there's no solution, sometimes there's an infinitely many solutions. And so I want you to see what those would look like if they happened. So let's say that this is my system. X equals negative 5y plus 4, 3x plus 15y equals negative 1. So we can see I've already got that first one solved for x, so I can take that and I can substitute it in. So this will be 3 times negative 5y plus 4 plus 15y equals negative 1. So I'm going to have to distribute. Okay, now when I go to combine these two x values together, look at what's going to happen. I have negative 15y plus 15y, which makes 0. They cancel each other out, and the only thing that's going to be left is 12 equals negative 1. That doesn't make any sense. So if your variables cancel out and you get a statement that is not true, because 12 is not equal to negative 1, then I could at this point say no solution. Now if this is one that we had graphed, then you would have two lines that are parallel to each other and they never intersect. That's why there is no solution. When you're solving by substitution, this is how you will know it's no solution. The variables cancel out and you have an incorrect or a false statement. Okay, so if we look at one other example, so let's say we've got x equals 5y plus 10, 2x minus 10y equals 20. Okay, so just like I did on that last one, I'm going to go ahead and substitute, and I'm doing this quickly because I'm trying to get to the end. Okay, I'm going to distribute that 2. That's going to be 10y plus 20 minus 10y equals 20. So look at your variables. 10y minus 10y. Variables are going to cancel out just like last time. So if we write down the only thing that's left, we've got 20 equals 20. Well, my variables canceled out, but the statement I have left is a true statement. It is not false like the last one. So this is the one that would be infinitely many solutions. If we were solving by graphing, we would have the exact same line, one line on top of itself, and it shares all of the points in common. Whenever you're solving by substitution instead, you'll see your variables cancel out and you have a statement left that is true, something that's equal to itself.